Okay, so here's another rule. We've last couple weeks we've been going over various shortcut rules for derivatives. We started out using the definition to find some derivatives, and then we went over some shortcut rules. And here's another rule, and it's called the chain rule, and it gives a formula for finding the derivative of a composite function. And it's going to, when used in combination with the other rules, it greatly expands our the functions that for which we have shortcuts. Anyway, the chain rule is there's in function notation. It's f of g of x is equal to f prime evaluated at g of x, and then multiplied times g prime of x. So that's in function notation. Function notation makes the composition, I guess, more obvious, although oftentimes it's more convenient to use Leibniz notation. I think it's maybe a little bit simpler looking formula in Leibniz notation. Derivative of y with respect to x is equal to derivative of y with respect to u times the derivative of u with respect to x. So here's an example. F prime of x, find f prime of x if f of x is the quantity 2x minus 3 to the second power. And so if we use the chain rule, well, actually we can do it without the chain rule. If we expand this, 2x minus 3 quantity squared is 2x minus 3 times itself, so it's 2x times 2x is 4x squared. Outer product is going to be 2x times minus 3. The inner product will be the same. Combine those, you get minus 12x. Last times last, negative 3 times negative 3 is 9. And then take the derivative of each term separately, and we'll get derivative of x squared is 2x. So you have 4 times 2x. Derivative of x is 1 times x to the 0, or just 1. So you have minus 12 times x to the 0. Derivative of constant is 0. So 4 times 2 is 8. So you have 8x minus 12 for the answer. And we can also do this in we can also do this using the chain rule. So the other way of doing it, so we want to take the derivative of we have the outside function is squaring. It's exponential. It's an exponent rather. It's x to the second power. Not exponential in the usual sense, but it's it has an exponent, and it's the inside function is 2x minus 3. So this is a composite function. So we want to take the derivative of the outside function with respect to the inside function, and then multiply it times the derivative of the inside function. So so here we use the power rule. So it's 2 times whatever was inside to the first power, and then this is the derivative of 2x minus 3 is just 2. We're going to have 2 times the quantity 2x minus 3, which also gives us 8x minus 12, which is the same thing we had before. So there's okay, so there's I'm going to do this chain rule using in slightly different ways. So let's I'll do it several different ways, but essentially it's the same thing. You remember we had sort of the function way of doing it, or we had the Leibniz rule. So this is sort of in between the two forms of doing it. Let's do it with the using the function notation here. I'll redo this here, and so we have again we have an outside function and an inside function. So this is a composite function. We can make g of x be the inside function. g of x is 2x minus 3. That's the function inside parentheses. So f of x is equal to g of x to the second power. If we g of x to the second power. So g of x is what's inside. So we want to first take the derivative of g of x squared with respect to g. So we take we use the power rule there. That's we have something inside function to the second power, and take that with respect to the inside function, and then times the derivative with respect to x of g of x. So this is so here we use the power rule. It's 2 times g of x to the first power, and this part is the derivative of g of x, which is this 2, and we end up with 2 times the quantity 2x minus 3, 8x minus 12. We could, if we express this in terms of Leibniz rule, so in Leibniz notation, the inside function is represented by u. So so we do a substitution, u equal 2x minus 3, and that means that y is equal to well, it's 2x minus 3 squared, but it would be u squared. We're just doing a substitution there. So we want, using Leibniz notation, this is the derivative of u squared with respect to u times derivative of u with respect to x. So the derivative of u squared is 2 times u to the first power, and the derivative of u, well, replace u by 2x minus 3. That's just going to be 2, and here we replace u by 2x minus 3 again, so it's 2 times 2x minus 3 times 2, 8x minus 12. So there's several ways of thinking about this, but essentially you want to take the derivative of the outside function with respect to the inside function, and then times it by the derivative of the inside function with respect to x, or whatever the original input was. Okay, so here's another example. So the inside function is 2x minus 3. The outside function is 12. So f prime of x, that's going to be derivative of whatever is inside parentheses with respect to what's inside parentheses there, times derivative of what's inside parentheses with respect to x. So we have the outside function is raising to the 12th power. Inside we have something else. So this is going to be 12 times whatever inside to 11th power times derivative of whatever's inside with respect to x. So let's put in what was inside there was the 2x minus 3. There's 12 times 2x minus 3 to 11th power times derivative of 2x minus 3 with respect to x. And this is just 2. This is the slope of this factor is linear, so it's just the number in front of x is the slope. So it's going to be 12 times 2x minus 3 to 11 times 2. 2 times 12 is 24. So 24 times the quantity 2x minus 3 to 11. Okay. So I mean, we could multiply this out as 2x minus 3 times 2x minus 3 times 2x minus 3 and avoid using the chain rule there, but the chain rule is going to make it much more convenient. Okay. Okay, here's another example. So this one we can write in exponent form as 2x minus 3 to the 1/2 power, and so the outside function would be raising to the half power. The inside function is 2x minus 3. So again, f prime of x is going to be derivative of whatever's inside to the half power with respect to the inside function times the derivative of the inside function with respect to x. So this is going to be 1/2 times whatever is inside, so minus 1/2 times the derivative of the inside with respect to x. So we can put the 2x minus 3 back in here. 1/2 2x minus 3 to minus 1/2 times the derivative of 2x minus 3 with respect to x. Well, the derivative of 2x minus 3 is 2, so it's going to be 1/2 times 2x minus 3 minus 1/2 times 2. Half of 2 is 1, so that's going to cancel. So we're just going to have 2x minus 3 to negative 1/2. And we can put it right back in radical form here. X minus 3 to the negative 1/2. A negative exponent is 1 over a positive exponent, so this is 1 over 2x minus 3 to the positive 1/2. And half power means square root, so it's 1 over square root 2x minus 3. Okay. Okay, so that's another example of use of chain rule. Here's another one. F of x is sine of 2x minus 3. So the derivative of f prime of x. So this is, here the outside function is sine, inside function is 2x minus 3. So this is the derivative of sine of the inside divided by the inside. And then times derivative of the inside function with respect to x. So this is sine is a cosine. So this is cosine of whatever was inside times the derivative of the inside with respect to x. And then we can put in the inside function, fill in the inside function. This is cosine of 2x minus 3 times the derivative of 2x minus 3 with respect to x. Derivative of 2x minus 3 is just 2, and we can put the 2 in front. Usually the numerical coefficient goes in front, so it's 2 times the quantity cosine of 2x minus 3. Okay, so that's another example. This next example, we actually have not just an inside and outside, but we have a inside and an outside and a middle function. So we want so f of x is sine squared of 2x minus 3, and this is actually a shorthand notation of the for sine of 2x minus 3 and the whole thing to the second power. So writing it out in longhand instead of the shorthand notation makes it clear, makes the composition a little clearer. The outside function is going to be squaring, raising to the second power. We have a middle function, which is sine, and then the inside function is 2x minus 3. So we have an outside, a middle, and an inside here. So the f prime of x is going to be derivative of what's in the square brackets, with respect to the square brackets, times derivative of what we have inside the square brackets. We have sine of the middle function. We have the derivative of sine of something with respect to that thing, and then we have the derivative of the inside function with respect to x. Okay, so we have an outside, a middle, and an inside. This is squared. This should be squared here. Okay, so for the first factor, we can use the power rule. So this is going to be 2 times whatever's inside the square brackets to the first power. The second, we use the rule for the derivative of the sine. Derivative of the sine is the cosine. Cosine of whatever's in the round brackets. And then times derivative of the round brackets with respect to x. Okay, so this is going to be, so then we can fill in what's inside here. We have 2 times what's inside the square bracket, sine of 2x minus 3. And this will be what's inside the round brackets, cosine of 2x minus 3 times the derivative of 2x minus 3 with respect to x. And this last factor is going to be 2. So I'll have 2 sine 2x minus 3 cosine 2x minus 3 times 2. Usually the coefficient, numerical coefficient goes in front, so 2 times 2 is 4. This will be 4 sine of 2x minus 3 cosine of 2x minus 3. And that concludes this presentation.